Hi guys, welcome to the National University of Malaysia, university that inspiring futures, nurturing possibilities. Today, I will bring you guys around UKM. Let's go.
Testing, hello, can you hear me? Right now, can you see the slide that I'm sharing? That's it. Thank you for the feedback. So I would like to start now. Right, so selamat petang. Assalamualaikum semua. Thank you for coming. So how's everyone doing? How about you?
About my doctor.
Okay. Alright. Okay, I hope everyone is staying safe and taking care of themselves. Rising COVID cases and MCO has been declared, so please stay safe. Right, so the class today is going to be short. We are not going to do a full 3 hour. In fact, I'm not even going to do a live class, right? But it is important, it is still important that you follow the lesson and learn the lesson that is scheduled today. So the topic that we are going to do today is scheduling resources and costs, which is a very important topic. So here's what is going to happen today. So for today's lesson, there is not going to be a live class, but I have put in the effort to make some videos. So I have put 3 short videos on UKM Folio. Now it is under the topic of scheduling resources and costs. So if you go to UKM Folio now, you should be able to see these short videos. Okay. So the first video is about 40 minutes long, or half an hour, something like that. Second video is about 5 minutes, and third video is also about 5 minutes. Okay, so in total, the duration for all the videos should take you less than an hour, less than 1 hour. So now it's 5 o'clock. If you start watching now, you should be able to finish by 6 o'clock, before 6 o'clock. Right, so these 3 short videos are about scheduling resources and costs. Okay, any questions so far? Am I clear?
No question, doctor.
No question.
Okay. All right. Right. So that's the first part that you should do. Please watch the videos. And also I have uploaded the notes that is explained in one of the videos. So you could read the notes. You can read the notes and look up some more materials if you want to. So that's number 2. Number 3, there is also a link on eQuiz 4 under the same topic of scheduling resources and costs. So it should be in the same topic on UKM Folio. So after you've watched these videos, which should take you about 1 hour or so. So you read the notes and then please answer the quiz. Okay. Right now the quiz is not yet open because I want you to watch the video first. I will open the quiz starting from 6 o'clock, and I will close the link of the quiz 9 o'clock today. So from 6 p.m. to 9 p.m. You should take the quiz, eQuiz 4. So the quiz is about scheduling resources and costs. So number 4, in order for you to take the quiz, you must sign into UKM student email. Okay, so please sign into UKM issued emails. Don't use any other email or Yahoo Mail or your social Gmail. That will not be accepted. Use your UKM student email because it comes with your ID. So it's easy for me to track who has not taken the quiz and who has taken the quiz. Okay, so that's number 4. And about the quiz itself, number 5, the quiz is not timed. Okay, so there's no time limit for the quiz. It's not timed. Once you start taking the quiz, it's not timed. You can take your time. You can go back to the video and notes if you cannot answer anything. And the quiz is open book anyway. It is not timed, but the quiz will only open between 6 p.m. and 9 p.m. today. So make sure you take the quiz today between 6 p.m. and 9 p.m. And finally, you can only do the quiz once. You can only submit the quiz once. There's a link, there's a submit button at the end of the form. You can only press it once. But after I close the link at 9 p.m., you will not be able to submit the quiz anymore. Okay, so that's what we are going to do today. So hopefully there's no problem with you. Is there any question for today's activity, today's lesson?
No question.
All right. Is there? I can also allow questions for anything about the course, anything that you want to ask about the project. Is there any question?
So far, no, Doctor.
Right. Thank you. Anybody else?
Doctor,
Yeah.
can we get the feedback on the progress report 1 ke tak ada?
Okay, that's a good question. I have not had the time to check your progress reports yet. And what I will do is I'll read through your progress report. And if I have any issue, I will contact the group leader. If you are not contacted, then your topic and your progress report is fine. Is that okay?
Okay, thank you, Doctor.
Right, thank you. Because there are 40 groups in total, all of you, so I need some time to go through all your reports. Okay, any more question? Last call for questions. Anything?
No, Doctor.
All right, thank you. So go ahead then. You can go to UKM Folio and watch the videos and take the quiz starting from 6 o'clock. And if there's no question, I would like to end this session. Please take care of yourself. And tomorrow, next week is already your mid-semester break and Hari Raya. So selamat Hari Raya from me to anyone who is celebrating. And I'll see you soon again. All right.
Thank you, Doctor.
All right. Thank you.
Thank you, Doctor.
Thank you, everybody. Don't forget to
Thank you, Doctor.
Thank you. You
Thank
too.
you,
Take
Doctor.
care. You guys are awesome. Thank you.
Thank you, Doctor.
Thank you. Take care now. Bye-bye. Thank you.
Bye.
Selamat Hari Raya, Doktor.
Selamat Hari Raya sama-sama kita.
Hi guys, welcome to the National University of Malaysia, university that inspiring futures, nurturing possibilities. Today, I will bring you guys around UKM. Let's go!
Hello and welcome to Chapter 8.
Where you
Chapter 8. My name is FAIZ, and in this lesson, we are going to learn about scheduling resources and costs. So here's the overview of the chapter. So we are going to learn about the different types of constraints and scheduling, and then we are going to discuss about the methods of allocating resources, and then we are going to talk about splitting of activities, and finally we are going to conclude with project cost baseline. So first, let's talk about the types of project constraints. So the first type of project constraint is called the technical or logical constraints, whereby the activities that occur in your project must occur in a specific sequence. So for example, if you have two activities in a project, let's say activity A and activity B. So if activity A must end before activity B starts, so that means these activities are technically or logically constrained, whereby the activities must occur in that specific step or specific sequence. So activity B cannot start before activity A, and activity A must end before activity B starts. So that's the first type of constraint, which is technical or logical constraint. The second type of constraint is called the physical constraint, whereby the activities cannot occur in parallel because they are affected by environmental conditions. And I will explain this in the later slide, in the next slide. And the third type of constraint is called the resource constraints, whereby the activities in your project are constrained by the absence or shortage of resources that are needed in the activities. So resources in a project could be people, such as manpower with a very specific skill set, or it could also be materials and also equipments. Now these examples illustrate the technical and resource constraints. So let's first look at the technical constraints in figure A. So the topmost figure here, you have the activities for a project of building a house. So you start by pouring the foundation of the house, and then you construct the frame, and then you build the roof. So these three activities are logically constrained or technically constrained because they must occur in this very specific sequence. So for example, you cannot build the roof before you actually have the foundation. So therefore, these activities must occur in this specific sequence. The next example of a technical constraint is a project for producing a software. So you start by having a design of the overall architecture of the software, and then you code the software, you write the lines of the software, and then you test the software. So again, these activities are logically or technically constrained because they must occur in this specific sequence. So for example, you cannot test the software before you actually code the software, and you cannot code the software before you have an overall design of the software. So that's the examples of technical constraints. Now let's look at the example for resource constraints. So in figure B here, you have a project for holding a wedding reception. So you have these three activities which actually can occur in parallel simultaneously because they are not dependent on one another, right? So you can have the activities for purchasing the refreshments, decorating the hall, and hiring a band in parallel simultaneously, and finally you hold the reception, right? But if your project has a limited manpower, if you only have one person to do all these three activities, so obviously these three activities cannot occur in parallel or simultaneously. So that one person has to do these activities one by one. So as a result, these activities in B are now reduced to activities in C, whereby that one person has to do these activities one by one. So he first has to hire a band, and then decorate the hall, and to purchase the receptions. So in this example, the project of holding that wedding reception is said to be resource constrained, And that limited resource that this project is having is the limited manpower, whereby the project only has one person to do all these three activities. Now let's look at the classification of scheduling for different types of project. Now the first type of scheduling is for the time-constrained projects. Now in a time-constrained project, the project must be completed by a certain imposed date. So the deadline is fixed, the deadline is non-negotiable. So in a time-constrained project, the time is fixed, but the resources are flexible. So additional resources can be allocated to a time-constrained project to ensure that the project meets schedule or completed on time. So that's the first type of scheduling, which is for the time-constrained project. The second type of scheduling is for the resource-constrained projects. Now, in a resource-constrained project, the level of resources that are available for that project cannot be exceeded. So the project is constrained by resources. The resources cannot be exceeded and the resources are fixed. But the time is flexible. So the resource-constrained project can be delayed if the resources are not adequate to meet the demands of the resource-constrained project. So as a summary, in a time-constrained project, the time is fixed, the deadline is fixed, the project must be completed on a certain time, on a certain date, but the resources are flexible. But in a resource-constrained project, the resources are fixed, so the resources cannot be exceeded, the level of resources are fixed, but the time is flexible. So a resource-constrained project can be delayed, but if the resources are not adequate to meet the demands of the project. Now let's talk about the resource allocation method for time-constrained projects. Now time-constrained projects must be completed on a certain date by an imposed date, so the deadline is fixed. It is non-negotiable. So the focus of time-constrained projects is the optimal utilization of the resources over the duration of the project. So you don't want to overcommit or overspend on the resources in a time-constrained project. Now this would require the use of leveling techniques that balance or smooth the resource demands over the entire duration of the project, as well as using positive slack, which is delaying the non-critical activities in the project so that the resource utilization throughout the project is optimized. Now this is an example of a project of a time-constrained project that uses positive slack to smooth out its resource demand over the duration of the project. So this is a project for a botanical garden, and it uses these backhoe tractors as its resources. So this is a time-constrained project, and the project must be completed on day 24. And there are 7 activities in this project, starting from design until planting, and the number of resources needed by each activity is indicated in the box of the activity. So for example, you have layout activity, which requires 2 backhoe tractors, and then you have walkways activity, which require 1 backhoe tractors, and so on. Now, I want you to note that there are 2 types of arrows here, and they indicate different things. The first type of arrow is the vertical arrows. For example, you have a vertical arrow that connects the design activity to layout activity. So what this means is that the design activity must be completed before the layout activity starts. So similarly, the layout activity must be completed before the walkways, irrigation, and fence and wall activities can start. So that's what these vertical arrows indicate. Now the other type of arrow is the horizontal arrows. So you have this horizontal arrow in the irrigation and fence and wall activities. So what this means is that the horizontal arrows indicate slack, positive slack, which tells you how many days or how much time this activity can be delayed without delaying the completion date of the overall activity. So this arrow here this horizontal arrow on the irrigation box tells you that the irrigation activity can be delayed by 6 days from day 10 until day 16. It can be delayed by 6 days without delaying the completion date of the overall project, which is on day 24. Similarly, you have a horizontal arrow on these fence and walls. So this fence and walls activity can be delayed for 6 days without delaying the completion date, the overall completion date of the whole project, which is on day 24. And again, since this is a time constrained project, so the completion date is non-negotiable. You cannot delay the completion date of the project. Now in chart number 2 shows the number of backhoes required for each day throughout the project. So from day 1 until day 4, for example, you require 2 backhoes from the activity of layout. And then from day 4 until day 10, you would require a total of 4 backhoes for activities, walkways, lighting and fence, and so on until the end of the project. So immediately that you can see that the resource demands, the resource profile over the duration of the project is non-uniform. It has a peak and a valley. So ideally you would want to smooth these resource demands, and also you would want to reduce the peak demand of the project. So the peak demand of the project occurs between day 4 until day 10, where the peak demand is 4 backhoes. That is the maximum number of backhoes that is needed for this project. So what can you do to balance, to smooth these resource demands, and ideally you would also want to reduce this peak demand? So you can use the slacks, the positive slack for activity fence and walls or irrigation. Now in this particular example, the fence and walls can be delayed for 6 days without affecting the completion date of the project. So this is what happens in the last chart here. The fence and walls activity is delayed by 6 days. So as a result, from day 10 until day 16, the number of resources, the number of tractors that are needed has increased from just 1 backhoe. It is increased to 3 backhoes needed, as shown in the last chart here. And the positive effect of that is that the peak demand from day 4 until day 10, originally you would need 4 backhoes from day 4 until day 10, but because you delay the fence and wall activities, you push it 6 days later. So as a result, you would just require 2 backhoes from day 4 until day 10. So you have achieved 2 effects here by using the positive slack for the activity fence and walls, which is you delay the activity fence and walls without delaying the completion date of the project. You have achieved 2 things. The first thing is that the overall resource demand of the project is now more smooth. It doesn't have any particular peak or valley. And you have also reduced the peak demand of the project. Originally, the peak demand of the project is 4 backhoes. You would need 4 backhoes for the project. This is the peak demand for 4 tractors. But now the peak demand throughout the entire of the project is just 3 backhoes. You would just require a maximum of 3 backhoes to complete the project. So from 4 backhoes, you have reduced to 3 backhoes. That means a savings of 25%, which is a huge savings for a project. And you have achieved this without delaying the completion date, the final completion date of the project. So again, this example illustrates the use of positive slack, which is delaying non-critical activities in order to balance, to smooth the resource demands of the project. So the resource leveling technique for time-constrained projects that we have discussed just now has these advantages and disadvantages. So the first advantage is that the peak resource demand, the maximum resource demand of the project is reduced. And we saw this whereby the maximum demand of 4 tractors for the botanical garden project is reduced to just a maximum demand of just 3 backhoe tractors. So the peak demand is reduced, and the number of resources, the level of resources that are needed over the entire duration of the project is also reduced, and the fluctuation in resource demand is minimized. But the disadvantage is that we have lost some flexibility because we have used up the positive slack. We have delayed the non-critical activities, so therefore we have lost some flexibility. And simultaneously, we have increased the criticality of all activities. So since we have delayed the activity which can be delayed, so it is now becoming more critical that the activity is completed on time so that the project can be completed on time. Now let's look at the scheduling method for resource-constrained projects. Now, as you know by now, there are two types of project. The first type is the time-constrained project, whereby the time is fixed. The project must be completed on a certain fixed deadline, and the deadline is non-negotiable. The second type of project is the resource-constrained projects. Now, in the resource-constrained projects, the resources are limited in quantity or availability. So the level of resources cannot be exceeded. So for example, resource-constrained projects might have a very limited number of manpower, maximum number of manpower, or equipments, or tools, machineries that are allocated to this project, and it cannot exceed the number of the resources that are allocated. So the activities in a resource-constrained project are scheduled using these heuristics, which is a rule of thumb, which have this order of priorities. So the first priority is that for activity which has minimum slack, which means activity that has that cannot be delayed. So this type of activity gets the first priority to be scheduled. And the second priority is for the activity with the shortest duration. And the third priority is for the activity which has the lowest number of identification number. And I will demonstrate this in the next few slides. So to apply this heuristic method is by using the iterative process. So you repeat the process over many times throughout the project duration, from the first time period until towards the end of the project, and you schedule the activities based on this order of priorities. Now let's look at an example of applying the heuristics on a resource-constrained project. Now this is the network diagram of a project to develop a software. And the resource that is needed in this project is programmers, the number of programmers. So each box tells you an activity, and each box tells you how many programmers that the activity needs. So for example, this box here, this activity number 1 here needs 2 programmers, activity number 2 here needs 2 programmers, and also activity number 7 here needs 1 programmer. So I'm going to go through very quickly on how to read the numbers on each of these boxes, what it tells you. And we are going to refer to this legend. So ES means early start. That means how soon can the activity starts. So for this box here, the earliest it can start is day number 10. Similarly for this box here, the earliest it can start is day number 2. So that's ES. Next is ID. ID is identification, or how we identify that activity. So this box here has ID number 7. So this is activity number 7. Similarly, this is activity number 4 because the ID is number 4. This is activity number 1. This whole box is activity number 1 because ID is number 1. Okay. So ES, ID. And then we have EF. EF means early finish. When is the earliest that the activity can finish? So this activity number 7 here, earliest it can finish is day number 12. Similarly for activity number 3 here, the earliest it can finish is day number 6. Right? And then SL. SL means slack. How many days can the activity can be delayed without affecting the completion date of the project? So for activity number 7 here, the slack is 0. So that means this activity cannot be delayed. activity number 4 here has a slack of 6. That means this activity number 4 can be delayed for 6 days without affecting the overall completion date of the project. Similarly, this activity number 5 here has a slack of 2 days. That means activity number 5 can be delayed for 2 days without affecting the completion date of this project. Then RES. RES means resource. How many programmers this activity needs. So activity number 7 here needs 1 programmer. Activity number 4 here needs 1 programmer. Similarly, activity number 2 here needs 2 programmers. SL is slack here. And then LS. LS means late start. When is the latest that the activity can start, is allowed to start? So activity number 7 here, late start is 10. Activity number 5 here, late start is 8. Activity number 6 here, late start is 6. Okay. Dur is duration. How many days that the activity will take? So for activity number 7 here, it will take 2 days. Activity number 6 here, it will take 4 days. Activity number 3 here, it needs 4 days. Okay. And finally, LF. LF means late finish. When is the latest that the activity is allowed to finish? So activity number 7 here has LF of 12. That means the latest that this activity will finish is day number 12. Activity number 4 here, LF is 10. So therefore, the latest it can finish is day number 10. Okay. And you can use this information to calculate different values in the box. So for example, you can calculate EF by summing together ES plus duration. So early start plus duration gives you EF. So if you look, for example, at activity number 7 here, early start is day number 10. And this activity needs 2 days. That means the earliest it can finish is day number 12. So 10 plus 2 is equal to 12. Similarly, for activity number 4, earliest it can start is day number 2, and this activity requires a duration of 2 days. So 2 plus 2 equals to EF. That means, 2 plus 2 is equal to 4. EF is 4. So for activity number 4, the earliest it can finish is day number 4. Similarly, LS plus duration is equal to LF, and you can verify by just by looking at any of these activities. So LF is equal to 2 plus duration equal to 4 gives you LF of 6. So latest activity number 3 start is on day 3, and this activity requires 4 days, so that means it will finish latest by day number 6. Okay. And slack. The slack can be calculated by taking the difference between LS and ES, or LF and EF, right? So let's look at activity number 4 here. Slack is equal to LS of 8 minus ES of 2. That gives you 6 days. So this activity number 4 can be delayed for 6 days without affecting the completion date of the project. LS can be calculated by taking the difference of LS minus ES. 8 minus 2 gives you 6. Similarly, you can also take the difference between LF, which is late finish, minus early finish. 10 minus 4 gives you 6. Right. So I would encourage you to try and read all these activities based on this legend here and verify the calculation which I've just told you about, so that the next few steps will become easier for you. Next, we convert the network diagram into this resource loading chart. So we have all those 7 activities listed here, from activity number 1 until activity number 7, along with the resources needed, which is the number of programmers needed for every activity, along with the duration, early start, late finish, and slack. So as you can see, activity number 1 here needs 2 programmers, and the duration is 2 days. Early start is 0, so it starts on day number 0. It takes 2 days, so early finish is day number 2. Now let's look at activity number 2 2 here, it needs 2 programmers. The duration is 6 days. So from day number 2, it will finish on day number 8. So that's 6 days altogether. It also has a slack of 2 days. So this activity can be delayed for a further of 2 days without affecting the overall completion date of the project, which is on day number 12, right? Activity number 4 here has a slack of 6 days. So that's why you see these 6 empty boxes here, which indicate that this activity can be delayed for 6 days, right? And then take a look at the bottom line here. You have the total resource load in the number of programmers throughout the project. So from day 0 until day number 2, for example, you would need 2 programmers. From day number 2 until day number 4, you need 5 programmers, and so on towards the end of the day. But we have a problem, and our problem is that we are only allowed a maximum of 3 programmers throughout the project, right? So the maximum resource that is allowed to us in terms of programmers, number of programmers, is just 3 programmers. So obviously we have a resource constrained project, and our resource is limited. Our limited resource is in the form of the number of programmers that is allowed to us, whereby we cannot exceed 3 programmers throughout the project. Okay, so what we're going to do is we need to reschedule these activities by making use some of the slack in such a way that the total resource load throughout the projects never exceeds 3 programmers. So that's what we are going to do in the next few slides. Right, so from day number 0 until day number 2, we only need 2 programmers for activity number 1, so we don't have any problem there because we don't exceed the number of resources available, which is 3 programmers, right? But we have a problem starting from day number 2, whereby originally we need 5 programmers, which is 2 programmers coming from activity number 2, 2 programmers coming from activity number 3, and 1 programmer for activity number 4. So initially we require 5 programmers, but we only have 3 programmers. So what we can do is you can use the slack for activity number 2. So we can delay activity number 2 for 1 day. So that means slack now becomes 1, from 2 to 1, and early start now becomes day 3. So we delay by 1 day. Activity number 2 starts on day 3, and the total resource load, the number of programmers that is needed now from day 2 until day 3, becomes 3 programmers. So we are within limit, right? So that's how we do it, and we keep doing this until the total resource load throughout the project remains within budget, remains within limit, which is a maximum of 3 programmers. So we keep doing this from period to period, from day to day, and also from activity to activity. So it's an iterative process. So if we keep doing this for activity number 2, we need to keep doing this for activity number 2, and we have actually exceeded the number of slack. Slack now is -2. In order to keep our total resource load never exceeding 3 programmers, we end up exceeding the slack for activity number 2. So that means activity number 2 now starts on day number 6. It requires a duration of 6 days, so that means it will end on day 12. So we have exceeded the slack that is allowed for activity number 2. But it is tolerable in a sense because this is a resource constrained project, so the priority is not to exceed the number of resources that is allowed. A little delay is tolerated, but we need to keep it to a minimum. So the priority is never to exceed the number of resources. So we keep doing this from day to day, from period to period, and throughout the activities as well, making sure that the total resource load doesn't exceed 3 programmers, right? So as I said just now, this is an iterative process. You have to do it day by day and throughout the project. And finally, we end up with this final schedule. And what it looks like is that the completion date of the whole project is delayed by 2 days, right? So activity number 2 is delayed by 2 days. We have exceeded the slack. Similarly, we have the same thing occurs for activity number 5 and activity number 7 here. So the whole project is delayed by 2 days, right? But we have successfully reduced the maximum load, total resource load throughout the project to remain within budget, within the limit, which is 3 programmers. So we never exceed that, we don't exceed that now, right? So this is how it's done for final resource constrained projects. It's an iterative process. You go through the schedule, you go through the time period, day by day and activity in making sure that the total resource load that is used throughout the project does not exceed the limit of resources that is allowed for the project. So what are the impacts of resource constrained scheduling, which we have discussed just now? So firstly, the flexibility of the activities are reduced because we have used up the delay or the slack that is being allowed for the activities. And in addition, the criticality of the events are increased because it is now more important that the activities are completed on time, because any more delay would add further delay to the whole project, right? And you can also see that the scheduling becomes more complicated and the traditional CPM is no longer meaningful. Some sequence of events can be broken, and in some cases, parallel activities can also become sequential after the scheduling is done. Now let's talk about splitting of activities. Now, splitting is a scheduling method that is used to create a better schedule or to increase resource utilization, right? So when an activity is split, in a splitting activity, what happens is that the work is interrupted, and the resource that is used on that work is then deployed to another work. And when that other work has been completed, the resource is returned back to this interrupted work, and the work is resumed, right? So splitting is feasible when the startup and shutdown costs of interrupting that work is low. But unfortunately, splitting is also considered one of the major reasons why projects fail to meet schedule, because of the startup and shutdown costs. So here's a diagram that shows how splitting is done. So initially you have one whole activity without any splitting that is not interrupted. And let's say there's another activity that needs the resource that is used on this activity. So say for example that other activity needs the machinery that is used on this activity, or the manpower that is currently being used by this activity. So what can be done then is that this activity is interrupted. It is split into 2 parts or 3 parts, and each time the activity is interrupted, the machine or the manpower that was working on this activity is deployed on that other activity. And when that other activity is completed, that resource is returned back to this interrupted activity, and the activity is started back again to resume with activity B and C. Right. So as you can see, there are interruptions, there are costs in terms of time or possibly focus of the manpower when the activity is interrupted. So splitting of activities is only advisable when the startup and shutdown costs are relatively low, so that we do not unnecessarily delay this activity. So by now you could see that scheduling is not a straightforward task. The examples that we have used just now are simple projects, but modern day projects are much more complicated than that. So obviously the scheduling of the resources and activities for much more complicated. Projects would also be more complicated. But scheduling is very important because it confers a few benefits. So scheduling ahead of project implementation leaves time for consideration of reasonable alternatives. So it would scheduling lets you plan ahead and consider the trade-offs between cost and time, and in case where there is a change in priority. Also, scheduling of resources provides information for time-phased budgets, time-phased work package, which I will explain in the next few slides. And by scheduling your resources ahead of time, you could also try to predict or try to minimize the impact of unforeseen events, and you could also assess the amount of flexibility that is available on the resources. Having a schedule of resources and costs, we are now able to develop a time-phased budget. Now, a time-phased budget is a budget that is phased according to the work done and also to the time that the work is supposed to be completed. So the reason why we need time-phased budget is because we want to be able to determine if the project is on schedule, ahead of schedule, or behind schedule. And also we would be able to determine if the project is under budget or over budget. So in order to know if the project is over budget or under budget, ahead, behind, or on schedule, we need to compare the project progress with the project cost baseline or planned value. Now, to create a time-phased budget, the work package must be assigned to a responsible person or a department, and then the planned value, the planned budget, is compared against that work or the time where that work is supposed to be completed. And this is done using a system called earned value. So earned value and planned value will be explained in later chapters. So here's an example of a work package. So you have the WBS interlinked with the OBS, and at the intersection here you have the work package. So this, for example, this work package here is to design a circuit board, and it has a total budget of $300 for 2 work packages for 2 different works. And this is an example of a time-phased work package. So what it means by time phase is that the budget of $120 is now time phased. It is allocated specifically according to specific work period, work weeks, and also it tracks what work must be done. And it's, in this example, this is the labor cost for the task work. So by having a task-phased work package, we will be able to track how much progress has been done as far as the work is concerned, and how much money has been allocated or has been earned on that completed project. Right. So ideally, at the end of this process of having a time-phased work package, we want to be able not only to track the progress of work according to time, but also we want to have a planned value. We want to be able to compare the planned value against the earned value. How much money has been allocated for each specific work at each specific time, and how much work has actually been completed for that particular week on that particular time. So again, the planned value and earned value systems will be explained in later chapters. Alright, so we have arrived at the end of this lesson. Thank you for your attention and staying. And these are the key terms. As a summary, these are the key terms that are important in this chapter. So the notes of this chapter will be also pasted on UKM Folio, and I would also encourage you to Google or read up more on these terms. Right, so thank you very much.
Hello and welcome to Exams PM's YouTube channel, where we will teach you how you can pass your PMP or KPAM certification on your first try. Today's topic is what is the difference between resource leveling and resource smoothing. So it rarely happens that you have all the resources as per your project requirements in order to complete your project. Even if you have them during execution, there's risk that they may be taken away from you and you have to make do with lesser resources than it's available in order for you to complete your project. So this is where resource optimization techniques come into play. Even when you have all the necessary resources, then it is still your responsibility to use these resources as efficiently as possible to save costs for your company. In order to achieve this objective, there's two resource optimization techniques you can use, and these are resource leveling and resource smoothing. So these techniques will allow you to complete the project with minimal obstructions. And in this video, I'm going to show you what the difference between resource leveling and resource smoothing are. So let's start off with resource leveling. So you use resource leveling when you have limited resources and you can extend the schedule. So resource leveling is used when a critical resource may not be available for a certain period of time or duration, or you had to share a resource with another project. The demand for the resource basically exceeds the supply. So what we can see here is that in week 1 and 2 on the left-hand side of the graph, the resource is working more than 40 hours a week in order to complete the project. Now, although this is feasible on paper, in reality, this is not as feasible. So what happens is that by using resource leveling, you're extending the schedule. So instead of completing this project in 5 weeks, you're completing it in 6 weeks in order to account for the fact that your workers can't work for more than 40 hours per week. So in essence, when resources are not available to help you complete the project schedule during the time frame that you need them to complete it on, then you extend the project duration to accommodate these changes. Now, the second resource optimization technique is called resource smoothing. You use resource smoothing when you have to optimize the resources and you cannot extend the schedule. So what we can see here from this diagram is on the left-hand side, on week 1 and 2, you're using the resource at full capacity of 40 hours. In week 4 and 5, you're using it a lot less. So what you're doing in resource smoothing is you're readjusting their schedule a little bit so that they have an even amount of work throughout the 6 weeks. So since you can't extend the schedule, the project completion date and the critical path will stay the same. Here, the activities cannot be delayed more than their total or their free float. Okay, so let's compare and contrast the difference between resource leveling and resource smoothing again. In resource leveling, the project end date does change. So this is usually used for tasks that are on the critical path. So if there is an extension of the schedule, the entire project will take longer to complete. And it is usually used for over or under allocation of resources. In comparison, in resource smoothing, the end date of the activities doesn't change. So given the dates that you have, you're just readjusting the schedule a little bit so that the amount of work the resource has to do from week by week is roughly the same. So there's no change to the critical path. The activities can be delayed based on how much float you have in that specific activity. And it is usually used to even out uneven allocations. So a major difference, resource leveling changes the end date. Resource smoothing does not change the end date. You're just adjusting uneven allocations. So I hope you learned a lot from this video. That is the difference between resource leveling and resource smoothing. And if you want to learn more tips like this, and if you want to learn how you can pass your PMP certification within the next 6 weeks, we will teach you all the strategies you need on our free masterclass. Simply sign up at www.examspm.com/free. We're going to go over how to read the process chart, go over how you can interpret all the ITTOs or in PMBOK guide, the exact strategies you need to use, the study plan you can use even if
Welcome to this video on finding the critical path on a project network. I'll be working with this activity schedule for a project. I'll be constructing a project network, doing forward and backward passes, determining the project completion time, calculating slack values, and finally stating the critical path. I will be using this node convention here, as you will find in Quantitative Methods for Business by Anderson, Sweeney, and Williams. A here is the activity being described, and T represents the expected activity duration or time. ES is the earliest time the activity can start. EF is the earliest finish time. LS is the latest start time. And LF is the latest finish time without extending the minimum completion time of the project. I usually like to start with a sketch to make it easier when drawing the full network. Activities A and B have no predecessors, so they can begin as start. Activity C needs A to be completed before it can start. D needs both A and B completed. E needs D. F needs C and E, and G depends on E. Since F and G have no successors, they go to finish. So here is the network with the activity nodes displaying the letters and times. So let's do the forward pass. A has no predecessor, so its earliest start time will be 0, or right away. Since it has 7 weeks to be completed, its earliest finish time will be 0 plus 7, which gives 7. B also has an earliest start time of 0, and with an activity time of 9, it will have an earliest finish time of 9. Now, C needs A to be completed before it can start. Since the earliest finish time for A is 7, then the earliest time C can start is 7. And with an activity time of 12 weeks, C will have an earliest finish time of 12 plus 7, which gives 19. D, on the other hand, needs A and B to finish before it can start. Since the earliest finish time for A and B are 7 and 9 respectively, and D needs both of them to finish in order to start, then the earliest time D can start is 9. In other words, the highest of the earliest finish times preceding an activity will be the activity's earliest start time. So D finishes at 8 plus 9, which gives 17. E here has only one predecessor D, and so can start at 17 and finish earliest at 26. F has predecessors C and E. Since the higher earliest finish time is 26, F can start earliest at 26 and finish at 32. G also can start earliest at 26, since it has only one predecessor E, and G can finish earliest at 26 plus 5, which gives 31. Note here that although G is the last letter, it doesn't have the highest earliest finish time because F has 32, so we say that the project's completion time is 32 weeks. In essence, the project's completion time is the highest of the earliest finish times at the finish node. Now let's do the backward pass. Since the project completion time is 32 weeks, the latest finish times for the activities at the finish node, F and G, has to be 32. That is, F and G cannot be completed in longer than 32 weeks. Next, we obtain the latest start times by subtracting the activity times from the latest finish times. For G, the latest start time will be 32 minus 5 to give 27. For F, the latest start time will be 32 minus 6, and that gives 26. Now, E has two successors, F and G. The latest start times are 26 and 27 respectively. As a result, the latest time E has to finish has to be 26 in order for F to start. In essence, when doing backward pass, the latest finish time of an activity must be the minimum of the latest start times of its successors. Thus, the latest start time for E will be 26 minus 9, which gives 17. Now, D has only one successor, E. So the latest finish time for D will be the latest start time for E, which is 17. And the latest start time will be 17 minus 8, which gives 9 for D. Activity C has one successor, F. Therefore, the latest finish will be 26 for C, and latest start will be 14. A has two successors, C and D. The minimum of their latest starts is 9. So the latest finish for A will be 9, and its latest start will be 2. Activity B has one successor, D, with latest start of 9. So the latest finish for B will be 9, and its latest start will be 0. The backward pass is now complete. Now, slack for an activity is defined as how long the activity can be delayed without extending or increasing the project's completion time. And it is calculated as LS minus ES or LF minus EF. So the slack for A will be 2 minus 0 or 9 minus 7, which will be 2. The slack for B will then be 0. For C, it will be 7. For D, 0. For E, 0. For F, 0. And for G, 1. Note, for example, that activity C can begin anytime between week 7 and 14, and it can finish anytime between 19 and 26. Thus, C can be delayed for up to 7 weeks, and the project will still be completed in week 32. Activities B, D, E, and F, on the other hand, cannot be delayed at all without extending the project's completion time. So, for example, if D is delayed by 2 weeks, then the project completion time will be extended by 2 weeks as well, from 32 to 34. The activities with 0 slack are called critical activities, and they form the critical path, which is the longest path in the network. So the critical path here is B, D, E, F. And that's it for this video. Thanks for watching.